2.1 notes introduces our unit on logic. So logic includes inductive reasoning, deductive reasoning as well, but we're going to talk about inductive reasoning today. Inductive reasoning is where you notice patterns and then make a conclusion based on those observations and patterns. Then we can write a conjecture based on your inductive reasoning. So that's a concluding statement that we reached using inductive reasoning. So we're just going to look at these sequences down here and then write a conjecture about it. Use inductive reasoning. So here, I just want you to look at these and see if you can notice the next part in the sequence. Now, what did we do here? Between 38 and 31, 31 and 24, 24 and 17, and so on, we just subtracted 7 from the previous term. So what we're going to write for all of these is to generate the next term. Then we're going to say, here we're subtracting 7, so subtract 7 from the previous term. Number 2, you can pause the video and look for a pattern. Here though, it looks like if we take 2 times 2 and then add 1, we get 5. Take 5 times 2 and add 1 and we get 11. 11 times 2 is 22 plus 1 equals 23. So then 23 times 2 is 46 plus 1 gives me 47. And then we go on and do the same for all of these. 191 times 2 is 382. Then we add 1 and we get 383. So sometimes you have to look a little bit to figure out what these are. So we're going to say, to generate the next term, double the previous term and add 1. Then looking at number 3, do you recognize anything about those numbers? I could go on and show you a couple more here. What do we have here? What happens if you square 1? You get 1. 2 squared, you get 2. 3 squared, 2 squared, you get 4. 3 squared, you get 9. 4 squared, you get 16. 5 squared, so on and so forth. So we've got 49 is 7 squared, then 8 squared, 64, 9 squared is 81. So what I'm going to say down here is each term is a perfect square. So if we consider this term n, the nth term, this is like the first term, second term, third, fourth, whatever number we're squaring, we're going to call n. Okay, so if we're trying to say this is 9, So n equals 9 here. If we go on and we're trying to find n equals 100, we would square that, 100 times 100, and that would give us the nth term. So we're going to say to find the nth term, square n. So for example, when n equals 6, we square the 6, and so the 6th term is 36. So that would be the nth term. Make sure that makes sense to you. That's math terminology. All right, number 6 is a little different. You might recognize it if I write it like this. See what that is? 3.14, you should recognize. That is pi. So each term is a digit of pi. So to find the nth term again, find the nth digit of pi, you would probably have to look this up. I'm assuming you don't have it all memorized. I don't. Okay, so this is the first digit, second, third, fourth, fifth. So if n again is 6, this is the 6th term, then the nth term here would be the next digit, which if you look it up, you'll find out it is 9. If you don't understand the nth term thing, come and check with me and I will try to explain it a different way. Okay, now we have counterexamples. So counterexample is just an example that shows that a conjecture is false. Remember the conjecture we had at the top of the previous page. That was just the concluding statement we made about inductive reasoning. So that whole first page, we were using inductive reasoning to look for a pattern, and then we made a conjecture. So the conjectures up here were, like to find the nth term, find the nth digit of pi, generate the next term, double the previous one, and so on. Those were conjectures. So these are some conjectures that are written for us, and we have to determine if they are true or if they are false. And if they're false, we're going to provide a counterexample, which is the example that shows it's false. So let's look at the first one here, number 7. So the sum of any two consecutive integers is always odd. So thinking back to integers, it included negative numbers, 0, and positive numbers. So let's check and see on our positive numbers, sum of any two consecutive integers. So for example, 2 plus 3. That equals 5. Is 5 odd? Yes. Let's try it with negatives. So negative 4, and then plus, we just write the negative there. So negative 4 and negative 5. Could have done 3, but so that would be negative 9. That is also odd. So if we do negative 4 and negative 3, negative 7, yes, odd. Can you come up with any example where it is not odd? Can we come up with a counterexample? In this case, no, because this is true. Looking at number 10. If the area of a rectangle is 6 meters squared, 6 square meters, The dimensions must be 2 meters by 3 meters. So can we come up with an example? Remember, area is the length times the width. You can mark those any way you want. I just picked the length as the larger one. So yeah, if the length is 3 and the width is 2, yes, it is 6. What if we, though, had the width being 1 and the length being 6? So 6 meters times 1 meter would give you 6 square meters. So that one is false. And my counterexample is 1 meter by 6 meters. That one proves that that is not true. Number 12, vertical angles are never complementary angles. So using your knowledge from last unit, vertical angles, remember, are across from each other. So that's a set of vertical angles, and then this is a set of vertical angles. Is there a case where they can be complementary? Remember, complementary means they add up to 90. So is there a case where vertical angles can be complementary angles? So if we have a situation like this, remember, if one of those is a right angle, 90 degrees, they all are. So what if we have this situation? And we say that this guy is congruent to this guy. So this one here was an angle bisector. Okay. Let me mark what the lines are that we're looking at. So this line and this line, we can mark this guy right here and this one as vertical angles. Those are congruent. And if this was 90, this is also 90, which means half of that would be 45. Then down here, if this guy's 45, so is this one. So that is the only situation where they can be complementary angles. So what I'm going to say is, if the vertical angles are 45 degrees, then they are complementary.